In this video, I am going to explain about series inverter operation. The inverter plays a vital role in UPS. It is used to convert the direct current into alternating current of required voltage. In series inverter, two thyristors are used, thyristor T1 and thyristor T2. It has to be connected in series. Along with these two thyristors, the elements inductor, capacitor and resistor has to be connected in series, and this element is going to act as a commutation element. Commutation is nothing, the method to turn off these two thyristors, that is thyristor T1 and thyristor T2. The value of these three elements has to be selected in such a way that it has to satisfy the condition of underdamped oscillation, that is R square is less than 4L by C. Let IS be the source current, IL be the load current. When thyristor T1 is on, thyristor T2 is force commutated, and when thyristor T2 is on, thyristor T1 is force commutated. Initially, we have to consider the capacitor voltage to be a negative value. Once the thyristor T1 is turned on, the current flows in the direction given by a red arrow mark, that is, it flows through thyristor T1, L, C, R and back to source. When thyristor T1 turns on, that is, we are applying the gate pulse to the thyristor T1. The thyristor T1 turns on. Already, the value of R, L and C is selected in such a way that it has to satisfy the underdamped condition. Underdamped condition is nothing. It will produce an oscillatory waveform. Here, therefore, the load current will increase, reach the maximum value and then decrease back to 0. As I told before, initially the capacitor will carry the voltage minus Vc0. Once thyristor T1 starts to conduct, the capacitor charges and it increases from minus Vc0 to Vs plus Vc0. At the time when the load current becomes 0, the capacitor voltage would be Vs plus Vc0. Here, inductor is connected in series with the capacitor. Therefore, the inductor voltage will decrease as the capacitor voltage increases. So, initially, the inductor voltage will be Vs plus Vc0. It starts to decrease and it becomes Vc0 in the negative direction, whereas the capacitor voltage increases and reaches a level Vs plus Vc0. At that time, the load current becomes 0. As the load current becomes 0, this will force commutate. Force commutate is it will make the thyristor T1 to go into reverse biased mode. Therefore, thyristor T1 will turn off. Once thyristor T1 is turned off, the capacitor voltage will retain the same value at the time when thyristor is turning off. So, at the time when thyristor is turning off, the capacitor voltage is Vs plus Vc0. So that value is retained. Whereas the inductor voltage will instantly die to 0 because the inductor voltage VL is nothing, it is L into di by dt. So it is rate of change of current. So here the rate of change of current is 0. So since the rate of change of current is 0, the inductor voltage also becomes 0 and retained in the 0 value till the time period T2 to T3. So between the time T1 to T2, thyristor T1 is on and thyristor T2 is off. Between the time period T2 to T3, both the thyristor are in off state. At T3, thyristor T2 is triggered. That is, thyristor T2 is given with the gate voltage. Now the thyristor T2 will turn on and the direction of the current will be in the reverse direction. That is, it will be from R to C, C to L, L to thyristor T2. Therefore, the load current starts to increase in the reverse direction. As I told before, that is, RLC value is chosen in such a way that it will satisfy the condition of underdamped oscillation. Therefore, the load current will start to increase. It will reach the maximum value, then reaches the decrease to 0 again. Now, the capacitor voltage will also go in the reverse direction. That is, at present, that is, when T2 is turned on, the capacitor voltage is Vs plus Vc0. So this voltage will start to reduce and it will reach the value Vc0 in the negative direction. We all know that inductor will behave opposite to that of the capacitor since it is connected in series. Therefore, what will happen to the inductor voltage? Inductor voltage will start to increase from minus Vc0 to Vs plus Vc0. Here we have to note a point, that is, when thyristor T1 is turned off, at that instant I told that inductor voltage becomes 0 because there it depends on the rate of change of current di by dt. The current is 0, therefore the rate of change of current is also ultimately 0, so it is in the 0 value. But once thyristor T2 is turned on, immediately it will come back to the previous value, that is Vc0 in the negative direction. Now, from the value Vc0 in the negative direction, the inductor value will start to increase and it will reach the point Vs plus Vc0. So at that time, load current is 0. Now, this load current 0 will force commutate the thyristor T2. Therefore, the thyristor T2 will turn off. So as I have discussed now, what will happen? Once the thyristor T2 is turned off, both the thyristor will be in the off state from the time period T4 to T5. So at that time, load current is 0. Capacitor will be retained with the value that it was carrying previously at the instant when thyristor T2 is turned off, that is Vc0 in the reverse direction. Next, VL. The voltage across the inductor immediately will become 0 because the current is 0. Now, the next thyristor T1 will turn on only at the time T5. So from the time instant we can understand that there is a time delay between turning on of one thyristor and turning on of other thyristor. That is, between the time T1 to T2, thyristor T1 is on. And between the time T2 to T3, both the thyristor are in off state. And between the time period T3 to T4, T2 is turned on. And between the time period T4 to T5, again both the thyristors are off. So this time delay is given in order to make the thyristor to achieve its blocking capability. So that in order to prevent the short circuiting of both the thyristor, which may damage the device. So this process will continue. Now we will look into the time period of load current. Time period of this load current is nothing. It is equal to pi by omega r. This omega r is called as ringing frequency. I told that we have chosen the value of R, L, C in such a way that it has to give us the underdamped oscillatory circuit. So you are getting an oscillatory output. So the frequency of this oscillatory output they named as ringing frequency. And the condition for underdamped oscillation is R square should be, the value of R square should be less than 4 into 4 times of L value divided by C. Hope you would have understood. Thank you.